This is the exam review for semester 3. The subject is chemistry for grade 7. We first learnt about concentration. So we said a solution is a homogeneous mixture of one substance, so that's the solute. It's dissolved in another substance, which is the solvent. And the concentration is a ratio of the amount of solute to the amount of solvent, and it's calculated by the equation concentration equals mass, which is in grams, and volume, which is in liters, and the units is grams per liter. And as you can see in the figure, that the more solute we have, the more concentrated it is. So this is less concentrated, while this solution is more concentrated. Solubility is the maximum amount of solute that can be dissolved in a solvent. So if we put more solute, it will remain as a precipitate and will not dissolve. Factors that affect the rate of species dissolves is increase in temperature. So as we increase temperature, solubility increases. Stirring and crushing, so reducing the size of the particles. Solubility is calculated by mass divided by volume. Mass is in grams, volume is in liters, and the units is grams per liter. We then looked at if a solution is saturated and unsaturated. So to know if a solution is saturated or unsaturated, we compare the values obtained for concentration and solubility. So we calculate concentration and then we calculate solubility, and we compare the numbers. If the concentration is less than solubility, then the solution is unsaturated. If the concentration is equal to the solubility, then the solution is saturated. Physical changes, that's when the nature of the substance does not change. So in this change, no new substance is obtained, and it can be reversed. For example, ice is solid, it can convert it into water, but we can freeze the water and it'll go back to solid. Tearing a piece of paper, it can be reversed because it can be recycled. Dissolving sugar in water, we can separate the sugar from the water by distillation, and we'll still receive the sugar and the water. Crushing a can also be reversed by recycling. Chemical change is when a substance combines with another substance to form a new substance. For example, when we put sugar with sulfuric acid. This is irreversible. And in chemical change, we have products and reactants. A reactant is a substance that disappears during a chemical reaction, while a product is a substance that appears during a chemical reaction. Now we will do the questions in the exam review. Question 1. To study the influence of temperature on the solubility of a known solid, a student prepares saturated solutions of solid X at different temperatures. He records the results in the table below. So on a graph paper, we have to plot the graph that represents the variation of solubility as a function of temperature. And the axis is given. So every 1 centimeter is 20 degrees, and every 1 centimeter is 40 grams per liter. Okay, so let's draw the graph. Just a reminder here that the scale is 1 centimeter equals 20 degrees, and 1 centimeter equals 40 grams per liter. So we have to, for temperature, we have to go every 20, so 0, 20, 40, 60, 80, 100. And here every 40, so 40, 80, 120, 160, 200, 240, 280. And remember, we have to label this axis as well. Solubility, and that's the units, gram per litres. And now we plot. So 0 is 80, 20 is 120, 40 is 150, so it's roughly here, 60 is 180, it's roughly here, 80 is 215, 100 is 240. Okay, and then we connect the lines, and we have to do a title. Graph showing the variation of solubility as a function of temperature. Remember, we have to also label this axis. This is temperature, degrees Celsius. B says, what is the relation between the temperature and the solubility of solid X? As you can see here, as the temperature increases, the solubility is also increasing. Okay, so as the temperature increases, solubility increases. What is the solubility of solid X at temperature 30 degrees? So here we have to use the graph. Okay, so we see 20 and 40, so in the middle it's 30, so it's around here. Okay, you do a line until you hit the line here, and then you go across. So this is 35, okay, so 35 gram per litres. If you write 34, if you write even 30, if you write 40, okay, I'll count them as correct. Okay, so it just depends how the line is drawn. Okay, so any answer between 30 and 40 is correct. Question D says, what is the nature of the solution obtained by dissolving 300 grams of solid X in 2 liters of water at temperature 40 degrees? Okay, so first we have to calculate the concentration. Remember, concentration equals mass divided by volume. The mass is 300 grams and the volume is 2 liters. Okay, so concentration equals mass divided by volume, that's 300 divided by 2 equals 150 gram per litre. Now, nature means if it's saturated or unsaturated. So here we look at 40 degrees. Okay, so at 40 the solubility is 150, and remember when we said that when concentration equals to solubility, it is saturated. Okay, so this solution is saturated. Solution is saturated because the concentration equals solubility. E says, what is the nature of the solution obtained by dissolving 50 grams of solid X in 0.0 liters of water at temperature 20 degrees? Justify your answer. So again, we do exactly the same thing. Concentration equals mass divided by volume. Mass is 50 grams. The volume is 0.5. Okay, so concentration equals 50 divided by 0.5, which is 100 grams per litre. Remember, we said, so we look at 20 and we've got 120 is the solubility. Remember, we said that when concentration is less than solubility, then it is unsaturated. So here we write this solution is unsaturated because the concentration is less than the solubility. Calculate the mass of solid X dissolved in 100 ml of water at 80 degrees. So, remember, solubility equals mass divided by volume. And if you want to use the triangle to help us, it looks something like this. Okay, we need the mass. So the mass, rearranging the equation, is mass is solubility times volume. Now, we know the solubility, we can use our table here, because it says at 80 degrees, so we know that the solubility at 80 degrees is 215. So that equals 215 times the volume. Now the volume is 100 ml. Okay, so the volume is 100 ml. We work in litres, so we have to divide this by 1,000. Okay, which gives us 0.1 litres. Okay, we want this in litres, so we have to divide this answer by 1,000, and that is 0.1. So 215 times 0.1 equals 21.5 grams. Question 2 says, in an attempt to study the influence of temperature on the solubility of oxygen gas in water, we measured the solubility of oxygen gas at different temperatures. The results are shown in the graph below. This is the graph. So first question says, using the graph, complete the table below. So 0, here's 0. So what's the solubility? It's 7. The solubility at 4, we look here, look at 4, the temperature is, it's even marked for us, it's 20. Okay, so at 40, we look at 40, which is here, the solubility is 3. At 60, here we have to use the graph, so at 60, we go up to the point and then cross. So it's around 2.5. At 2, so we use the graph, it's 80. And at 100, we also use the graph. It's around 1.5. Two says, what is the solubility at temperature 50 degrees? We look between 40 and 60. We take roughly half. We use a ruler. So that's about around 2.8 or 2.9. I'm going to write 2.8. 2.9 is fine. So it's 2.8 the solubility at temperature 50 degrees is 2.8 gram per liters. Analyze the above graph. So, at temperature 0, the solubility is 7 gram per liters. As temperature, look at temperature, as temperature is increasing, as temperature increases, the solubility, what's happening to the solubility is that it's decreasing, okay, it's going down, so the solubility decreases. Till it reaches 1.5 gram per liters at 100 degrees, and that's how we analyze this graph. What can you conclude concerning the effect of temperature on the solubility of oxygen gas? We write, I conclude, in gases, when temperature increases, solubility decreases. Question 3 says indicate the true and false statements and correct the false ones. So A says a physical change is a change that cannot be reversed. So this is false. A physical change is a change that can be reversed. A chemical change is a change that cannot be reversed. That's true. A reaction is a substance that disappears during a chemical reaction. This is also true. A product is a substance that appears during a chemical reaction. This is true. When solubility equals concentration, the solution is unsaturated. This is false, okay? That's because we said that when concentration equals solubility, it is saturated. So, false when solubility equals concentration, the solution is saturated. F says when dissolving 227 grams in 1457 ml of water, the concentration is 125 gram per liters. Now it says concentration, so we know concentration equals mass divided by volume. We know that the mass is 227 grams and the volume is 1457 mils. Now we need to divide this by 1000 because concentration is always gram per liters, so that is 1.457 liters. Concentration equals 227 divided by 1.457, which gives us 155.79 gram per liters. Here we calculated that concentration is 155.79. Here it says it's 125 gram per liter, so it's false. When dissolving 227 grams in 1,457 ml of water, the concentration is 155.79 gram per liter.